Hello, welcome again to this YouTube channel. So today we're going to look at how can we find the points, the critical point for this particular function. Okay, so now we have a cubic function. Okay, so first things first, if you want to find the critical point, you need to tie your knowledge on the tangent line plus the maximum or minimum point, or either ways sometimes you have an inflection point. Okay, so um, we start with finding the prime first. Okay, the first differentiation for my for your dy dx. Okay, so in this case you just differentiate this particular function. Now you have 3 x square minus 12x, and then your 12 is just 0 right now. Okay, so we return we refresh our information about the critical points. All right, so remember what we have, for example, like this or like this. If let's say you want to find the derivative, the points, sorry, the point for this function, for example, this point, if you want to know the slope for this tangent line over here, okay, this is when you get the dy dx at this particular function here, over here. All right, so the special case for your critical point is when you have a tangent line. Okay, also a tangent line, but this one, your tangent line is exactly at a minimum, maximum, or a point where your differentiation, your first derivative changes its sign. All right, so we look at that one later. But at this particular juncture, what you need to do, what you need to know is how is it that can we find these points, okay, when your tangent line is like this, okay, or this point where tangent line is like this. Okay, this is a special situation for your dy dx. Okay, so when this occur, when this tangent line occur like this, okay, this is when your dy dx equal to 0. All right, you imagine why. Okay, you can see, for example, oh, what is my slope over here? Okay, if you look at the slope is just the same, right? For example, you have the changes of your x. This is your x, and the changes for your y. Okay, so actually you have y2 minus y1. Okay, I refresh back your memory. X2 minus x1, this one is your m. But now when you have these particular issues, okay, you can see your y does not change. Okay, if let's say your y is over here, okay, this is for example y2. Okay, this tangent, okay, the slope of the tangent, even though your x changes, if let's say you select one point over here and one point over here, you have the difference of x. All right, this is your x1 and this is your x2. Sorry, I'm doing it a little bit messy, okay, but I think you get the point if you really listen carefully at this presentation. Okay, but now your y is just using the same point. Okay, so that's why your y now is just y2 minus y2, right? And then your x is still the same. Okay, that's why you get 0 over here. Okay, this is the concept of why your dy dx must equal to 0 when you need to find your critical point. Okay, why this thing happens. Okay, so knowing this information, okay, we come back to our problem, y equals to x cube minus 6x squared plus 12. Okay, once we have that information, we can just simply put this equal to 0. Why? Because we have this one. All right, we have this one. Okay, once you have this, this is just the matter of you. I know you are very good at this. This is just solving your algebra problem. Okay, and then once you have this, you can equalize your 3x equals to 0, and then your other one, do not forget your sorry, your x minus 4 equals to 0. And then from here you know that your x equal to 0 and also your other x equal to 4. Okay, does this enough? I don't think so, right? Because our question is finding the critical points, okay? X equal to 0 and x equal to 4 is not a point, it's a number, all right? It's a representation of your x and your y, but not a point, okay? So how to solve your point? You can just look back at your original y coordinate, and then you put your x equal to 0 in the first one. Okay, I also put 3, the power 3, just in case you forget about this. And then this one over here. And then you get 12. So your first point, your first critical point is 0, 12. And then we do the same one for the next point. Okay, your 4 to the power of 3 minus this one, just calculate using your calculator only, no need to bother yourself with this. Okay, you calculate and then you get negative 20. So your next point, your next critical point now is, sorry, 4 and negative 20. All right, so basically this is your critical points. If you want to write in a proper form, then that's fine. Okay, I recommend you write like this. Okay, so the critical point now, okay, is 0, 12, and also, okay, 4 minus 20. Now I'm talking about a critical point only, all right? I didn't talk about whether our critical point is a maximum or is it a minimum, or actually it is not minimum or maximum. It is an inflection point, okay? So we are looking at that particular points there in the next lesson. Okay, so I hope you enjoy the video. I'll see you guys in the next video. All the best.